Okay, so in this video we're going to talk about the show methods and do a couple more examples. So in example 5 we're given by y equals x squared, and yet the other y is equal to 4x minus x squared. Okay, so in this case I'll read through the diagram. So we have this function here is going to be 4x minus x squared, because by factoring out x equals 0, x equals 4, so that means it's going to be 4 right here. Okay, so this is 4, and then this is x equals 0, so in that case if I erase this part here, that means my top function, my bottom function are, so this is my top function, so this part here, that's my f of x. And this is my g of x. Okay, so we have 4 ways of doing it. Well, they ask us to do 3 different things. So rotate around the y-axis, part B is rotate around x equals 4, and then rotate around x equals negative 3. So in that case, I want you to do these up. Okay, so in each of these rotations, we have to figure out what the volume is. Okay, so let's go ahead and first of all draw the cross sections. So since show method is parallel to the axis of rotation, that means my cross section is going to be vertical. That means I have to integrate with respect to x. So for this one, for number A, the volume is equal to 2 pi integral. Okay, look at my bound. So this is 2. This is 2 because point of intersection you have x squared is equal to 4x minus x squared. 2x squared, and then you have 4x minus 4x squared equals 0, so that means factor that, 2x, x minus 2 is equal to 0, so x equals 0, x equals 2. So in that case you have 0 to 2 in this regard. Okay, so that means it's going to be integrated from 0 to 2. Okay, that means in this case, my top function, my bottom function, my top function is f of x, bottom function is g of x, so top function here is 4x minus x squared. Okay, minus my bottom function, which is just going to be x squared. Okay, and my axis of rotation is going to be x equals 0. So that means I'm integrating with respect to x. In that case, my radius is dependent on x. So that means my radius is going to be x dx. Okay, and that concludes part A. But you have to go ahead and look for the derivative. Well, look for the integral for this one, and you're done. Okay. So part B. The question says we're revolving this thing around x equals 4. So in that case, it's beyond the axis, it's on the positive axis of my y-axis. In that case, 2 pi from 0 to 2. And I have, again, my upper function, my lower function are the same function. So in that case, you have 4x minus x squared, that's my f of x, minus x squared, that's my g of x, my bottom function. And then I multiply by, in this case, my radius is going to change between 0 to 4, right? So that's, in that case, 4 minus 0 gives me 4. That's my total radius. That's my radius. 4 minus 2, that's this radius. And that means this radius is total of 2. That means my radius is going to be 2 minus x. Sorry, 4 minus x dx. Okay? And then the next one, C, volume is equal to 2 pi between 0 and 2. And revolve around x equals negative 3. That's below below the y-axis. That means, again, top function, bottom function are the same. So we have 4x minus x squared minus x squared, bracket. Again, now here's the part with the radius will change. My largest possible radius is between 2 and negative 3. So that means the biggest is possible is 5. So that means we have x plus 3 dx. Okay? So in that case, since our largest radius is 5, my upper bound is 2, 2 plus 3 is 5, so that's good. Okay, so I'm integrating this way. So in that case, my largest radius is 5, my smallest radius is from negative 3 to 0, which is 3. Okay, so in that case, 0, plug in 0, you have 0 to 3, and that makes perfect sense. So there you go. That is my 5th example. So I'm just going to label this. This is my F, this is my F, this is my F, and this is my G. This is my G. Okay? So hopefully that made sense. So all you have to do is go ahead and integrate that, and you have your volumes. Okay? So in the next example here, I have revolving around 6 different axes. Okay? So the function I have in mind is x equals 4 minus y minus 2 squared. So that means it's a parabola, but shifted 2 to the right, and then up 4. Okay, so in that case we have up of 4. In that case, that's what my function looks like. Okay. So now, first one is y-axis. Okay. And then part B and C. These are all revolving around the vertical axis. D, E, F are revolving around the horizontal axis. So in that case, let's go ahead and do A, B, and C together first. So since we're revolving around the vertical axis, my cross sections are all vertical. Okay, because I must be parallel. My cross sections are parallel to the axis of rotation. Okay, so let's start off with A. Okay, revolve around the y-axis. So we have the volume is equal to 2 pi integral. Okay, since we're revolving around the vertical axis, we have to rewrite this in terms of x and y. In terms of x. So that means let's go ahead and solve that first. Okay, let's start off with that. Okay, so we have to rewrite this. Okay, so we have switch this out to x is equal to 4 minus y minus 2 squared. Okay, and then switch them around, we have y minus 2 squared is equal to 4 minus x. So y minus 2 is equal to the positive and negative of 4 minus x. So y is equal to 2 plus minus 4 minus x. Okay, this is the positive component. Okay, let's use blue. This is my positive component. This is the positive of this, and this is the negative of this. Okay? So very much what we have here is those are my numbers. So let me move it up here. Negative 2 is equal to plus minus square root of 4 minus x. Y is equal to 2 plus minus square root of 4 minus x. Okay, so for A revolving around the y-axis. Okay, so that means my volume is equal to 2 pi. Okay, in that case, we're revolving. Okay, so this is where 2 is. Okay, because it's half, it's a parabola. So my bounds are from 0 to 4. 0 to 4. My upper bound is the positive component. So in that case, we have 2 plus 4 minus x. And my lower bound is the negative component, so minus 2 minus 4 minus x. Okay, and then that's my height. Now, my axis of rotation is what, x equals 0. So that's going to be whatever's changing here is from 0 to 4. So in that case, it's dependent on my x dx. Okay, let's double check. When x equals 0, my lower bound, I'm over here. When x equals 4, I'm up here. So that means the biggest possible radius is 4. My smallest radius is 0. So that means this one is good to go. Okay. Now, for part B, I shift my axis to x equals negative 3. So that means you're shifting that way. So that means, again, volume is equal to 2 pi between 0 and 4. F and G, F minus G is still pretty consistent here. So in that case, 2 plus square root of 4 minus x minus 2 minus 4 minus x, bracket the whole thing. And then I have my largest possible radius here is from 4 to 3. That's 7. My smallest radius here is 3. So in that case, we have 4 minus x dx. Okay, let's double check. When x, wait, oh, should be, x plus 3. So x plus 3 dx. Okay? Let's double check. If I plug in 0, my biggest radius here is 3, from here to here. Makes sense. My next radius is from 4, that's my largest upper bound, so 4 plus 3 is 7, so that's this radius over here. And that makes sense too, so that's good to go. Now, for C, my axis of rotation is at over here, so x equals 5. So I have my volume is equal to 2 pi, again, pretty standard, in this case, F minus G is always consistent here. So 2 plus 4 minus x minus 2 minus 4 minus x, bracket the whole thing. And then now, axis of rotation is at x equals 5. My smallest, the biggest possible thing is 5 minus 0, which is 5, right? And my smallest radius is 5 minus 4, which is 1. So in that case, 5 minus x is what we're looking at. Okay, let's double check. 5 minus 4 is over here. 5 minus 0, I'm over here. So that means that's the size. Okay. Now, last we have D, E, and F. We're going around x equals the x-axis, y equals 4, and y equals -3. So it's all drawn up here. So over here, my axis of rotations are horizontal. Therefore, my cross-section is going to be horizontal as well. Okay? So that means I'm integrating with respect to y. Okay? So in this case, I think we're pretty much good to go because this function is already given in terms of x. My lower bound is, in this case, 0, so we're good. Okay? So that means for D, we have the volume is equal to 2 pi between, okay, I'm going from 0 to 4. Okay? 0 to 4. Now, with the upper bound, my function here is just going to be this minus this. So then my top function here is just going to be x. My bottom function is going to be 0. So that means this function is f of y is equal to 4 minus y minus 2 squared. And this is g of y is equal to 0. So top minus bottom, so we end up with 4 minus y minus 2 squared minus 0. Okay? And I'm revolving around the x-axis, so that means my largest possible is 4 and my smallest is my 0, so in that case it fits here. So let's plug in x dx. Okay? Now, 2 more. Okay, the volume for this one here, for E, we have to shift it up to y equals 4. So again, pretty standard, 2 pi, 0 to 4, 4 minus y minus 2 squared minus 0, that's again f minus g. Okay? And my largest possible radius is 4. So in that case, from 4, this distance here is 4. And my distance when I'm f equals 4, I have 0. So I'm coming in from the bottom up. So in that case, we have 4 minus y dy. Okay? So think about it like this. We start over here. The largest possible is 4. Largest is, in this case, 4 minus 0, which is this distance 4. And my smallest distance is when y equals 4, so 4 minus 4 will be up here. So that one's good to go. Now, f is the last one. V is equal to 2 pi, 0 to 4. Again, pretty standard. 4 minus y minus 2 squared minus 0. And my axis of rotation is at y equals -3. So, when y equals 0, my distance here is 3. When y equals 4, my distance here is 7. So in that case, we have y plus 3 dy. Okay? Let's double check. When y equals 0, I have 3. Okay, 0. Okay? When y equals 4, I have 7. So plug in 4, 7. That makes sense. That means this function here is good to go. So I'm going to go ahead and label this. This is f, f, f. Bottom is g, g, g. Okay, now here we have this function. So I'm going to draw a line here. And this is f, g, f, g, f, g. Okay? That's it. Hopefully this video helped you. That's all. Okay? See ya.